May 27, 2017. Mount Everest. Minus 30 degrees Celsius. Wind that can freeze exposed skin in under 3 minutes. A man is moving upward alone, above 8,000 meters. No oxygen tank, no safety rope, no team. And here is the detail that should stop you immediately. After everything he went through up there, he came back with all 10 fingers intact. That man is Kilian Jornet. And in the next few minutes, I am going to show you exactly why that single fact is one of the most medically unexplained details in the history of elite sport. What happened on that climb should have ended him. During the first of his 2 Everest ascents that week, Jornet spent 12 hours alone in the dark above 8,000 meters. Sick, stopping every 10 steps because his stomach had completely shut down. Moving so slowly his body was barely generating any heat at all. In conditions that can freeze exposed skin in minutes. 6 days later, he went back up. That was his second summit in under a week, without supplemental oxygen, without fixed ropes. The medical reports confirmed no cold injury, no lost tissue, nothing amputated. To understand why that is extraordinary, you need to meet Beck Weathers. May 11th, 1996. Same mountain. A storm rolls in, and a Texan ophthalmologist is caught in the descent. Within hours, he is lying face down in the snow at 8,000 meters, in a hypothermic coma, completely unresponsive. The expedition leader radios base camp. The message is simple and final. Beck Weathers is dead. Leave him. And they do. Because there is no other option. You cannot carry a dead man down Everest. The next morning, Beck Weathers stood up. Literally. He got to his feet and started walking toward camp. His right arm was a solid block of ice from the elbow down. His face was unrecognizable. He had been lying in the open at altitude for over 10 hours. Declared dead twice in 24 hours. He survived both times. The price was everything. Both hands amputated. His nose surgically rebuilt. Parts of both feet gone. Beck Weathers was not a weak man. He was a fit, experienced high-altitude climber. His body did exactly what a human body is supposed to do when the cold wins. And the cost was catastrophic. 1953. A man named Hermann Buhl stands on the summit of Nanga Parbat, the 9th highest peak on Earth, having just made the first ever solo ascent of an 8,000er. It is 7 in the evening. He cannot get down before dark. No tent, no sleeping bag, no oxygen. He is wearing a shirt, a pullover, and a thin anorak. He spends the night standing on a narrow ledge because there is no surface wide enough to lie down. By an extraordinary coincidence, that night was almost unnaturally calm for Nanga Parbat. Temperatures near 0 Celsius instead of the usual minus 25 or 30. That meteorological miracle is almost certainly what kept him alive. He descended the next morning having lost permanent sensation in both feet. Alive, but permanently changed. 2 legends of the mountains. Both survived, both left a part of themselves up there forever. So is Kilian simply fitter than everyone else? His VO2 Max, the measure of how efficiently the body processes oxygen, is reportedly between 88 and 92 milliliters per kilogram per minute. Roughly double an untrained male. Elite marathoners typically hit 60 to 75. That seems like the obvious answer. Except in 1988, a Swiss physician named Oswald Oels tested 6 of the greatest high-altitude climbers alive, including Reinhold Messner, the man who made the first solo ascent of Everest without oxygen in 1980. His finding was devastating to that logic. Their lab values were, in his own words, far below those of world-class long-distance runners. Ordinary numbers. Nothing exceptional. So VO2 Max alone does not explain Everest survival. And that means it does not explain Kilian either. Something else is happening. But here is what your body does the moment it senses serious cold. Your autonomic nervous system makes a decision that is as ruthless as it is brilliant. It cuts blood flow to your hands, feet, and skin, and reroutes everything inward. Heart, brain, lungs. It performs triage, deciding which parts of you are worth saving. And the fingers, toes, and nose are deemed expendable. Imagine standing on that Everest ledge, feeling your hands go progressively numb, realizing they no longer feel like yours. That strange, almost peaceful disconnection from your own extremities is not calm. It is your body making a decision on your behalf. Sacrifice the edges. Save the center. This mechanism is called peripheral vasoconstriction. It is what destroyed the tissue in Beck Weathers' hands. It is what froze Hermann Buhl's feet. In both cases, the core survived. In both cases, the periphery paid. That is the system working exactly as designed. And here's what happens next. When vasoconstriction shuts off blood flow long enough, ice crystals begin to form inside the tissue itself. First in the spaces between cells, then inside the cells. The crystals pierce membranes and destroy tissue architecture. And then, when the climber is finally rescued and begins to rewarm, the real damage arrives. Blood rushing back into damaged vessels triggers an inflammatory wave that causes microclots to form inside the small capillaries. What the cold did not finish, the body's own recovery response completes. This is why frostbite damage is often dramatically worse 24 hours after rescue than it appeared immediately after exposure. It is not only the cold that kills the tissue, it is surviving it. So how does Kilian apparently escape this? 3 factors begin to outline an explanation. Some confirmed science, some expert-level speculation, and I will tell you which is which. First, metabolic heat reserve. His documented VO2 max means that even at altitude, running at a fraction of sea level efficiency, his engine generates more metabolic warmth than most climbers produce at full effort. He runs hotter just by existing. Second, non-shivering thermogenesis. Shivering burns oxygen you cannot afford at altitude. But there is a second heat generation system that works without muscle contraction at all. Brown adipose tissue produces heat directly inside the mitochondria without moving a single muscle fiber. No energy wasted on movement, just heat. A 10-day study in healthy adults exposed to mild cold showed measurable increases in brown fat activity, and subjects reported feeling warmer at the same temperature after just over a week. Kilian has spent decades living and training in cold mountain environments since childhood. The hypothesis that his brown fat operates with unusual efficiency is credible. But no published study has measured it in him directly. Third, genetics. Sherpas and Tibetan Highlanders carry gene variants that actually reduce the red blood cell response at altitude, keeping blood more fluid and microcirculation more efficient. This adaptation traces partly to Denisovan ancestry and is one of the most dramatic examples of recent human evolution ever documented. Does Kilian carry similar variants? No published genomic study exists on him. That question remains completely open. Before the 2017 Everest project, Kilian spent approximately 260 hours sleeping in a hypoxic tent, simulating up to 5,800 meters of altitude, and completed around 30 hours of high-intensity treadmill sessions at simulated 6,000-meter conditions. His blood oxygen saturation during those early sessions was around 70%. By the end of 1 month, it had risen to 85%. His body was being actively rebuilt in real time for what was coming. And Messner grew up in the Alps. Kilian was born on a mountain refuge in the Pyrenees at 2,000 meters. Cold and thin air were his first environment. His autonomic nervous system had been shaped by thousands of hours of cold hypoxic stress accumulated from childhood onward. This is not a training story or a genetic story. It is both, compounding across an entire lifetime. One more data point before we talk about what is trainable. And this one will genuinely surprise you regardless of your background.
The lowest core body temperature from which a human being has recovered with full neurological function in an accidental case is 11.8 degrees Celsius in a 27-month-old child. Full recovery. The lowest documented in an adult is 13.7 degrees Celsius. A Norwegian skier named Anna Bagenholm, trapped under ice with her heart stopped, rewarmed through a machine that circulated her blood externally. Full recovery. And in controlled surgical settings, documented survival at induced core temperatures down to 4.2 degrees Celsius has been reported. The medical consensus today is clear. There is no single temperature at which the human heart irreversibly stops. The phrase physicians now use is this: a patient is not dead until they are warm and dead. The cold does not kill you the way we always assumed it did. And Kilian Jornet may be the most extreme living demonstration of that principle ever encountered in an athletic context. So can you train any of this? A 10-day mild cold exposure protocol, just 2 hours a day at 16 to 17 degrees Celsius, measurably increased brown fat activity in healthy adults in a controlled study. They felt warmer at temperatures that previously triggered shivering. In 10 days. Altitude training, specifically the live high train low approach, increases VO2 max and hemoglobin, confirmed in a meta-analysis of 17 separate studies. The microcirculatory adaptations, better capillary density, and more efficient oxygen extraction at the tissue level are real and measurable. And a study published in the Proceedings of the National Academy of Sciences showed that subjects trained in voluntary breathing and cold exposure could consciously reduce their innate immune response to an endotoxin challenge, something previously considered impossible. Yes, these systems can be pushed with deliberate sustained training. The question is how far, and the honest answer from the literature is that while chronic training moves the needle significantly, the ceiling Kilian occupies involves a biological starting point that training alone cannot create. Somewhere between Beck Weathers losing both hands and Kilian walking away intact, there is a question the science has not fully answered. Not how is Kilian different, but how many people with a similar biological starting point simply never had access to a mountain? If a 260-hour hypoxic tent protocol can shift blood oxygen saturation 15 percentage points in a single month, and 10 days of cold exposure can measurably change how your mitochondria generate heat, then the gap between Kilian Jornet and the rest of us may be smaller than it looks from the outside. Or it may be larger. The science does not yet know. What it does know is this: the human body sacrifices its own periphery to save its core. Most people reach that edge and it costs them tissue, nerves, and body parts. A very small number of people seem to operate at that edge routinely, and the bill never comes due. Kilian Jornet is the most extreme, best documented version of that second category in the history of sport. Understanding him is not just about understanding one man. It is about understanding the outer boundary of what the human species is capable of, and how close that boundary might actually be to all of us. I am Sebastian from the Injury Breakdown. If you want to go even further down this rabbit hole, the next video I want you to watch is right here. It is about a man named Christian Blumenfeld, a triathlete with a documented VO2 max of 101. Scientists said that number was physiologically impossible. His story makes Kilian's look like a warm-up. See you there.